All right, hi guys. Thanks for attending my talk here. My name is Austin Erickson. I'm a PhD student over at the University of Central Florida down in Orlando at the Synthetic Reality Lab. And today I'm going to talk to you guys a little bit about dark mode and light mode style user interfaces. So right now, all of you probably have a smartphone either in your hand, in your pocket, or on your desk. It's to the point where we use these all over the place in so many different locations, under so many different contexts. And then as AR researchers, we kind of hope that one day we'll be able to do the same thing with AR devices. So some of the patterns that we see for phones are probably going to extend to AR devices in the near future. One of these patterns is the adoption of dark mode and light mode style interfaces. Over the past couple of years, these have really been adopted by all sorts of different devices and operating systems. They're now on Mac and Windows, iOS, Android, they're everywhere. We see light mode interfaces, which are kind of our traditional style UI. They consist of dark font on a light colored background. And then we have dark mode, which typically consists of a light colored font set against a darker colored background. So if we're designing a research project for a VR or a video see-through device and we wanted to use these two modes, this is kind of how they would appear to the user in the screenshot here. Of course, it's not always that simple. There are other devices that we like to use, namely optical see-through AR devices. And if you're to take the same implementation, these same UIs that you made, and pop them over onto an optical see-through display, you're going to see something that looks kind of like this. So we get this issue of transparency where on the light mode interface, you can see through the dark letters, and on the dark mode interface, you can see through the dark background. And in reality, it's even worse than how it appears in this video because even the light colored portions of the text are a bit transparent on optical see-through devices at the moment. So we have this bad issue of transparency on optical see-through devices, which makes them a little bit different compared to VR and video see-through, even if we have the same UI. So we really need to be aware of such differences when we're designing UIs for our research projects. So this brings us to the question of which UI mode should we use? As researchers and developers, if we're going to make one for our projects, which one should we choose? And the answer is that it does depend on a couple different factors. One of them, you could probably guess, is the XR device. So it depends on if we're using optical see-through or video see-through or VR. And then the second is that it depends on the physical or virtual lighting conditions of that user's environment. So my lab group has done a couple of research projects on this over the past few years, and we're just going to show you some of the results that we got in terms of which UIs are best for these certain circumstances. So for virtual reality and video see-through AR, we did a study where we checked visual acuity with this virtual eye chart. And what we found was that the best UI in terms of light mode or dark mode in terms of visual acuity was dependent on the amount of virtual lighting in the room. So if you had a very bright virtual environment, users performed better. They read smaller letters with the light mode chart, whereas if they were in a dim virtual environment, users performed significantly better and read smaller letters with that dark mode chart. And this kind of adheres to traditional UI guidelines. When we look at visual fatigue, we asked our users, how much eye strain are you experiencing when you're working with these type of interfaces? And what we found out was that the dark mode had significantly better scores for both lighting conditions. When we switch over to optical see-through, again, we have this issue of transparency, right? We can see through the letters on the light mode chart and we can see through the background on the dark mode chart. We ran pretty much the same study. And what we found was that in terms of visual acuity, it's a bit different. Dark mode actually produced better visual acuity in our participants under both lighting conditions. And we even looked at this over a couple of different backgrounds, and it was still dark mode every time. So we have this interesting difference there. And then we looked at visual fatigue again, and same as before, we had both dark mode interfaces, regardless of the lighting condition, were rated as significantly less visual fatigue for our users than the light mode. Um, so these are some things we need to be aware of as we're designing UIs for our research studies and as we're designing them for products that we may be developing. We need to keep in mind how these differences between the XR devices can affect the user, as well as how that virtual lighting comes into play when we're looking at those VR and video see-through devices. So to quickly summarize, we had those dark mode style UIs. They tend to reduce visual fatigue in all of the conditions that we've tested so far. They tend to increase visual acuity on optical see-through for all conditions that we tested. And they tend to be increasing visual acuity on VR and video see-through devices in dim settings. Then finally, we have that last kind of special case where light mode actually increases visual acuity for VR and video see-through devices when you're in bright settings. So some things to keep in mind. Thank you guys for watching my video here, and I will be around in the Discord if you're here live. Otherwise, feel free to email me at ericksona@knights.ucf.edu. Thanks. Bye.